Welcome to the series Through the Eyes of an Engineer. I'm gonna do a quick start introduction for programmers and get you up to speed in using Unreal Engine 4. There's lots of examples online which you may check, but I realize they never present a high level overview of how things work, which if they did, it would have saved me a week of searching, and I would have done it in about maybe 10 to 20 minutes, I would say. I'm assuming that you have programming experience. If not, maybe you should watch the other tutorials which guide you line by line on how to do things. So for Unreal 4, it uses C++11, and they have their Unreal 4 framework. They provide you with their C++ APIs, classes, etc., which is really good. I realized it feels like Java, even better. You rarely have to do things outside their framework. Also, they have build tools, and with their build tools, they're able to have reflection feature of C++, which is not available, as you know, in standard C++. And on top of that, they have the concept of blueprints, which is a graphical programming interface. If you are familiar with Simulink in MathWorks Simulink, that's graphical interface. This one is graphical interface where you have a flow which goes from left to right. But I like this one more. Now, notice that these two circles, the blueprints and UE4 build tools and reflection, touch with the editor, and the reason why I put it that way is C++ code by itself cannot interact directly with the editor. You need to have the Unreal 4 framework, but also you need to build the framework using their build tools to get the reflection in order for your code to be visible through the editor. Now, of course, it will interact with the game, but here specifically I'm talking about the editor. On the right side is another way we can look at this. We have C++11, we have UE4 framework, and we have the blueprints, and we can interact with the editor directly through blueprints, or in some cases through the C++ file. Now, in order to expose the C++ to the editor, we have to use macros, which we will discuss later. Here is an example for the first-person demo, which I got from creating a new file. And when you do that, you notice that there is a macro called viewClass and a macro called generated_body, and there's a header file called something.generated.h. These are automatically generated for you when you create a class through the editor. That's important. You have to create the class through the editor, not your own class. If you have any plans to make your class interactive with the editor, you have to create the class through their editor or do lots of manual labor. So these two macros is where all the magic happens. Also notice that this is part of their framework. Things that start with a U for Unreal, or A for an actor class, but later on that. So from a source file, you can do whatever you want in your source file. You compile that, and after compilation, you get the object, and you also get the metadata, which they generate for you. Now, the combination of both allows us to be able to use the compiled file in the editor. So what's a blueprint? Imagine that you have a compiled class and you have the metadata associated with it, and you can wrap these compiled class and the metadata with some wrapper, and you can add optional blueprint code or graphical code. After we compile all these, we get our blueprint. So a blueprint is a collection of parent C++ object. It's possible to have a child class. So basically, when we create a blueprint class, we can add our own graphical code and the metadata. So why do we use blueprints? If we can interact with them directly through the editor, it will save us lots of time, especially for calibration. Say, for example, you have a number called maximum speed. You don't want to go back and compile. You don't want to hard code your implementation inside your C++ files. You would put that you would expose that to the editor, and then you can calibrate your game easily through the editor. So how can we integrate C++ and blueprints? This is where the true power I feel of UE4 editor is. So you have to create C++ class using their editor in order to get those macros and generated files. Now, yeah, you have to compile that in order to see it, but normally it compiles the basic version for you. Then you can create a new blueprint from UE4 editor, and then you can select your C++ file as the parent for the blueprint. So you end up with this object, this square, which has blueprint variables, blueprint events, and you have the C++ in it, which you can expose macros. Through macros, you can expose methods and numbers. And all of these, the blueprints and the C++ code in the parent, can be used in the UE4 graphical editor to customize it. So let's do a live exercise. We're going to create a C++ class. We're going to inherit from the actor class. Why actor class? Because we can put that in our editor. We'll wrap it with a blueprint, and we will modify the blueprint. So I went ahead already. I went here, File, New Project. If you want to follow, I went to C++, C++ Basic Code, name your project, and create a project. I've done that already to save time. So I ended up with Visual Studio, and I ended up with, I added this already, but we can create that again. I ended up with this editor. So I'm going to go to File menu, if you want to follow along, New C++ class. So here is where I choose a parent class. Now, if I really do not want to choose, it's rare that I do not want to choose any parent class when I want to interact with the game. It's possible though. You can choose none. If your class is not listed here and you have something else, you can show all classes and select your parent. There's a lot. Basically, you can extend almost anything. So you hit next, and I'm gonna call that my actor example 1. So now it's creating and compiling the modules in order for the editor to be able to see it. And notice here, and by the way, if you do not see this, there is this arrow right here, which you can do that. You will not see the demo actor. I already created that, but you will see the my actor example 1. In here, you will get these two files, my actor example 1.h and cpp. Notice that you already have a generated body and you have this U class, and it's inheriting from a actor. There are also two methods that the game generated for us, which we're overriding, and I like this override keyword because it forces us to make sure, like, if the parent class doesn't have a function called begin play and we thought that we are overriding begin play, by putting override, the compiler makes sure that our parent has a virtual function called begin play that we are overriding. If I inherit from the wrong class and I put this and the parent class does not have begin play, the compiler will catch that for me because I am forcing it to override a function, and it will see that my parent class did not have that function. So this is what got auto-generated. Let's go back to the compiler. I went to content, right-click, new folder. You can call it whatever you want. I called it BP for blueprints. So I right-click again, or you can go to new over here, and I say blueprint class. So basically what I'm doing now is I'm creating this big box around my compiled object. Now, what I did is right click blueprint class, so I can search for my actor. There it is, my actor example 1. So this is what got created. I can right click rename or push F2 to rename. So I'll call this example actor BP. So what can we do with this? Now we can drag it. But also in C++, this is my example 1. I can attempt to drag it, but you see that it's being added, but I don't see anything. So if you look here, I added several examples, several instances, but we don't see them. That's because they are C++ and they're not blueprints. So I can add another blueprint and I can actually see it. Now, why can we see it? So I'm gonna double click on this actor and you will see that it has a default scene root. So this is what we see as this, how would I say, the white sphere. Now, somewhere here, we can see the parent class. I believe it's in the class default. So here you can see properties about the class itself and class settings. Oh, in the class settings, sorry, not class defaults. In the class settings, you see the parent class. Now, because we use their build tools, the UE4 build tools, you notice the space bar. It will put space between every capital letter. I can choose another parent class, but that defeats the purpose of what we're trying to do. We're trying to extend our class as a blueprint. So here is what we're going to do. We're going to add a static mesh. And a static mesh is basically some graphics associated with our class. And I'm going to add, let me search for a cube. I added cube, and let's say I put, doesn't matter what the material is. Now I have to compile, remember. Save, minimize, and here's our class. So now, using this class, we can do whatever we want in C++ and it will apply to this cube. So that's the whole idea of wrapping C++. with a blueprint, we can quickly do things that otherwise take too long in C++. Now imagine a game designer um, talks to the graphic designer and says, hey, I don't like the cube. Can you create a different shape? You as a programmer, you don't care about the exactness of the shape. All you care about is that you are an actor in our case, and you want certain properties and you want to put certain logic. Moving forward, so we finished our exercise. Now let's go and continue. How do we integrate C++ and blueprints? This brings us to the next point. Properties and functions. UProperty, which takes lots of parameters, and it allows us to expose variables to blueprint and editor, not just blueprint. UFunction allows us to expose functions to blueprint, and it allows us to receive events from blueprints. So UProperty takes several parameters. The proper word is not parameter. I forgot what the proper word used for macros. We'll call it parameter for now. By the way, I checked this URL to obtain information about these. It's not thorough because Unreal Engine 4 is in development. So if you want to expose a variable and you put edit anywhere, then you'll be able to set the value through the editor and blueprint. I haven't shown you what the blueprint code is yet, but what I mean is you'll be able to set it through the UI editor and the blueprint graphical coding. If you put blueprint read write, you can read modify through blueprints, not through the editor. And we'll try that. UFunction, if you put blueprint callable, you say, hey, this function jump can be called from my blueprint code. So this allows your blueprint to call your C++ function. If you put for the UFunction blueprint native event, it will add what's known as event to blueprint. So the blueprint code can use a new trigger. You can think of it as a trigger called has fired, and you can provide your own implementation of that. And we will see example of that. So to see the example, we're going to go through the live exercise 2. So we're going to use object from exercise 1. We're going to add a static mesh in C++, which can be set in blueprint. By add, I mean add a reference. We're not going to instantiate the object in C++. We're going to refer to it in C++. And we're going to let the actor move left and right. So there are many ways where we let the actor move left and right. Some are better than others. And what I will show you here is not the best way, but it's a very good way to learn about how to integrate C++ and blueprint. So we want to change location. If the location is far from certain bounds, we will call a blueprint. So basically, how do we do that? We will raise an event through the blueprint native event. This allows the C++, it will cause the C++ to trigger an event to blueprint. But all what we will do in our blueprint is dummy implementation. We may print to the screen and say, hey, function is called. Then we call C++ again. Basically, we could have called things here directly, but I want to show you how we can go to the blueprint, do something, and then we can call C++ to change direction. So our function has to be blueprint callable, the change direction. Also, anytime we push spacebar, we want to be able to call C++ to change direction. So basically, if I have an object moving from left to right, if I push space, I want it to go from right to left. Then I push space, I want it to go from left to right. But if it goes too far, I want it to change direction, etc. This is the exercise that we will go through. Now, I cheated a little bit. So I'm going to close this guy. I already created a demo actor, and let me show you how I did that. Together we created my actor example. I did the same thing. I went to File, New, Actor, Next, and I put here demo actor, and I created the class same as we created our demo actor, and I also wrapped the demo actor in a blueprint. So I went and I said blueprint class demo actor, and I selected this class demo actor. You will not see these, forget about these, and I created the blueprint. Now why did I cheat? Because I do not want to copy paste these guys again, but we will go through them together. So what you will have is this when you create the C++ actor. Now let's start adding variables. So we will write view property, which says, hey, this variable is going to be used in my editor or in the framework. We have to put a category. This category will appear as something like transform, rendering, input, actor. I'm adding something called CPP items. And I say I want to be able to edit this anywhere, which is blueprint, editor, etc. Then I say it's static mesh. What's a static mesh? You've already seen that. We added add component, static mesh, and we added a cube here. So in this case, our static mesh is inside the example actor. But in this guy, we're saying, hey, you're gonna tell me about a static mesh. So we have just a pointer. And now what we have here is int max x, and this will be the distance of how far our object can move. The reason why I added max y is just to show you what blueprint read write does. Now, new functions. Notice, by the way, all these are under public because we are accessing them from somewhere else. This is a blueprint native event. In the blueprint, I want to trigger using has fired. Now, for change to left, I want to change direction to left. It's blueprint callable. Basically, I want blueprint to be able to call this function back to C++. I put it under a category called CPP callback. Same thing as change to right. Now right click, build. If you write these and you build, I forgot about that, you will get errors. We need to go to our CPP file. You will see these files already available for you. The constructor, begin play, which is called when the game starts, tick, which is called every frame rate, and delta time is the time between two frame rates. I added my methods here. You have to add these, which are basically these. Now, here is a twist. For all blueprint native events, which are events in Blueprint. C++ can raise events to Blueprint, but also Blueprint's events can call Blueprint. What we can do is we can provide default implementation, and actually we must provide this function, and it ends with underscore implementation. So whenever you see Blueprint native event, you have to append this one to the function. How is this created? Well, when we build, there's lots of things going on in our building. And part of these macros and build toolchain, there's lots of magic there. One of them is it expects us to have this function name with underscore implementation. Now, once you add these three, you'll be able to compile. Okay, so I'll assume that you already compiled and wrapped your CPP with a blueprint. So I'm going to open this file under class defaults. Notice I have CPP items. It has X and it has my mesh. And that is because we have category is CPP items, and we can edit them because they are edit anywhere. Look at this one. Although it has a category, it's blueprint read write, but it does not appear. However, I'm gonna right click. By the way, this is where blueprint is. You may be here at viewport. There is construction script. You can do certain things in blueprint upon construction. And this is the event graph, is where you can graphically add code on top of your C++ code. So this is where the integration happens. So if I right click and I say max y, I can get the variable, or I can set the variable. Why can I only do it in here? This is blueprint, because I told him, hey, it's blueprint read write. Now, if you don't see these, make sure you click on the self here, not on the default scene root. So we will not need the max y for this example. So for the mesh, I want to add maybe this time, let's see what we have. Do we have a cone? Yeah, we have a cone, just to change it, you know. And max x, I want to say maybe 50. Compile, save. So if I try to drag this now, we have this guy here. Now, if I try to play, see one cube, but we don't see the other one, then you delete this guy. So the reason why we do not see the cube here is because, remember, we only have a reference. We don't have an object. So I'm saying, hey, this one refers to a cone. But we did not actually add a cone. So what technically should happen is, in our C++, we have to instantiate that object and add it to the root, and then it will appear here. Or I can simply go say add static mesh. Later in other videos, I'll show you how to add to root. But the reason why I showed you here now is to show you that, hey, it's only a pointer. Nothing's happening. We did select a cone. but actually it's not added. So that's very important to be aware of what is what. So now static mesh, I added component static mesh. So I'm doing what I could have done programmatically. Let me add a cone. But notice now how easy it is to create other things, because that's the power of Blueprint. So now, because they are connected, if I move the actor, the whole thing should technically move, and we can try that. So here's my cone. If I hit play, there's the cone. Let's put it in a nice place. Okay, save, play, there's the cone. All right, let's go back and see what we want to do. If location is far, call blueprint. Now, here's where the fun begins. I'm gonna create a private function variable. I'm gonna call it float. In my editor, here's my object. So this is the x, so this is the y. If I move this by 100, so we're gonna be moving the y, it seems, not the x. Or we can be moving the x if we are looking that way. We can later talk about these. This is a bit more advanced for the video. So right now we can focus on one direction. You know what? I will move the x. I will move the x just because I called my variable x. Float initial x. So this, I'm saying, hey, the time I start the game, I want to know what my initial value is. So let's instantiate that. By saying this can ever tick equal true, it means that, hey, we can keep calling this every frame rate. So I'm going to use this fact to implement what I want to implement. So let us get the actor's position. Now we are an actor class, obviously, because we extended the actor. So there's already lots of methods for us. One of them called actor location, and we notice it's a vector. So I'm getting the, let me see how to get the position. And I haven't done this in a while. It should be something where it says X, oh, yaw, Y. Oh, there you go. Alright, that works. So in here, I put my initial X. I need to know that. Now, begin play, it does nothing. We don't want to do it. Actually, you know what? This has to be here. Because when I'm constructing it, I don't know where it's gonna be in my scene yet. I cannot guarantee that. But when we begin play, everything has been set up in our scene. So let's move it to begin play. Now, what do? At every tick, I want to say actor location. So this is my method. And I want to say float equal location x. So now we know where we are. So I can say I want to add to it. Basically, it will depend on let's see, let's try this. Let's add 10 times 10.0 f times delta time. And now, basically, I incremented the x. So what we can say is there set actor location? Yep, there is set actor location, and it takes a vector, and we don't care about these for now. So I can say equal so what happened here is every frame I move it a little bit, I increment x. Now this is not everything we want, but this will get you started. I'm compiling, and let's go to our engine and play. Whoa, too fast. Let's slow it down, guys. It basically vanished from Earth. Let's do more like maybe this is too slow. We will see that. Oh. Alright, so I have to play with the numbers. I think I was adding to this guy. I don't need this guy now. So basically what we need to do is add some constant time times delta time to make it smooth, so that if our frame rate changes, we basically account for that. So build compile, and there you go. We have our object moving. Now I want to say that if it reaches maximum, or if it travels too far, I want to bring it back, etc. So I'll continue that in another video, because now we're gonna go too much into programming versus my PowerPoint, and we will implement this function. Thank you for watching.